Okay, good afternoon. And then I would like to start with the interview on the question that was given in the assignment. So the first question is to run like it was the first question. The first question talks about the intersection of two sets. So for the intersection of two sets, the first approach that I used is to first iterate through the set and check if each of its elements exists in the second state. So I'll iterate through the two sets and then also check if the element in the first set is common to the other set. And also to make this efficient, I'll pick smaller two sets to iterate through. So my first approach is that I'll create a new empty set to hold our result. Then I'll loop through each element in the smaller set. So let's call set A. Then inside this, so let's call it set A. So inside the loop for each element, I will check if it also exists in set B. Understand? And if it does, I will add that element to my result set. So after checking all the elements in set A, the function will return the result set, which now contains only the elements which are common to both. You understand me? So in terms of the big constant time performance, if we let n be the size of the set and m be the size of the larger set, so n will be the size of the smaller set and m will be the size of the larger set. So the time complexity is 0n. This is because we perform a single loop through the smaller set and then lookups in the second set take on the average constant time. Understand? So to make sure this works, I will use at least 3 test cases, like a standard case with some overloop, like 1 in the curly bracket 1, 2, 3 close curly bracket, and then in the curly bracket 2, 3, 4 curly bracket, which will return a result of 2 and 3 in the curly bracket. So a case with no intersection, like 1, 2, and then other curly bracket is 3, 4, should return an empty set. Understand? So an edge case where one set is empty, like let's say curly bracket open 1, 2, 3, and now curly bracket, it should also return an empty set. Understand? For the question 2, it talks about the union of two sets. So my approach is to create a new set to combine all the unique elements from both input sets. So the great thing about using a set for the result is that it automatically handles the duplicates of S. Understand? So first I will create a new set by making a complete copy of the first set. That's set A. Next I will iterate through every single element in the second set. That's set B. For each element from set B, I will add it to my result. If the element is already in the result set, the set data structure will just ignore it. If it is a new element, it will just be added. Understand? And also, once the loop is finished, the function returns the result set, which now contains a unique combination of all the elements from both the original set. So for the big constant performance, if set A has n element and set B has m element, the time complexity is, let's say, 0 bracket n plus m close bracket. This is because we essentially have to touch every element in both sets once. First to copy set A and then to iterate through set B. So finally, my key test cases would be a standard case with overlapping elements like 1, 2, 3 in a curly bracket, and then 3, 4, 5 in a curly bracket. So it will return a function which a result for me as 1, 2, 1, 2, 3, 4, 5, because it overlaps and joins all of them together. And also a case where the set is identical, like 1, 2, 3, and another set is 1, 2, 3. It will ensure a duplicate, returning a function of 1, 2, 3. Understand? And also an edge case where one set is empty, like 1, 2, 3 in a bracket, and then at n outset you should return a result of 1, 2, 3. You understand? Okay. And that's how I can implement my intersection and union function for sets.